Hello everyone and welcome to our CSD Crossminer course. We are going to discover what pharmacophore search is and what its basics and applications. So after watching this video, you will get better understanding of what the pharmacophore is and why the concept might be useful. You also will get familiar with Crossminer interface and understand how it can be used in your research. We will see how to build and modify a pharmacophore query, how to perform pharmacophore searches across the CSD and the PDB, and finally how to interact with the results you will get. Before getting deeper into the world of the pharmacophore search, let's see what tools are available from the CSD portfolio in general. CSD portfolio contains a number of different suites to support the design of your molecules, the assessment of solid form stability and properties, and the generation of insights from experimental structures and practice structure landscapes. Today we'll be discussing CSD Discovery Suite, which is aligned to help you design new molecules, new drugs, and we'll be honing on CSD Crossminer software platform, which enables pharmacophore search. But yeah, let's begin with discovering what CSD Crossminer is. CSD Crossminer is actually the result of collaboration between the CCDC and the pharmaceutical company Roche. It was born out of the desire to have a single search engine which is able to interrogate both major crystallographic databases of the world, the Cambridge Structural Database CSD and the Protein Data Bank PDB. Before we move on, it's important to understand why you may need it. So Crossminer is a very powerful pharmacophore search engine, but well, there are just a couple of examples which are very common in the community where you can apply Crossminer functionality. Let's imagine that you have a ligand which is 100% binds to a target of an interest and has some activity. But its properties, like for example physicochemical properties, are poor and you want to improve them. What you can do is to create a model which imitates the ligand's chemical groups which are critical for the interaction with the target and search known compounds which fit to this model. Using this approach, you can find new compounds which keep the known interactions with the target but may have another physicochemical properties. And we are going to take a closer look at this pipeline a bit later in our demo. You can also have an opposite problem. So, for example, you know your target and you know the pocket where you want a ligand to bind to your target, and you can imagine actually which interactions of your potential drug with the target are desirable and which are not. What you can do is to imagine or even calculate chemical properties that have to be present, and you can calculate at which locations they have to be present in your desirable ligand. Based on this, you can create a pharmacophore model of your drug and find molecules which fit into it. So yeah, there are many more applications of CSD Crossminer. It can be used for a hit-to-lead stage of drug discovery when you improve the binding property of the compound that you have. You can also identify off-target effects. It also can help in lead optimization, providing an understanding of which modifications can be tolerated in the binding site. It is also the ideal tool for scaffold hopping that can help with resolving of IP problems and lead to increased bioactivity and better pharmacokinetics. Overall, and more generally, Crossminer provides you with a great way to create new ideas in drug discovery projects. Getting even more detailed description of what pharmacophore search can do for you, it can give you an opportunity to design absolutely novel models that mimic established ligands to improve physicochemical properties or solve pattern issues. Also, as I have already mentioned, it is a very good way to perform scaffold hopping, and the aim of this would be to retrieve a diversity of ligand topologies that can be used as scaffolds for lead optimization. And of course, you can use pharmacophore search to interact with unexplored parts of the binding site and to help improve binding properties of a ligand. If we are looking more specifically at CSD CrossMiner, it can help you to determine common protein binding sites to predict selectivity and off-target effects. It can also shed light onto cross-pharmacology between protein targets and determine structural motifs that bind in similar environments to find insights for drug design and optimization. And these capabilities in CrossMiner are possible due to the fact that we have, for example, PDB database built in, which includes ligands and their binding sites. You can also build in your in-house database which has this information, and that can be very helpful in your drug design process. So yeah, to summarize, CSD CrossMiner is the tool for building pharmacophore queries, and we're going to get into details more about that and understand what pharmacophore query is. This is a tool for searching any structural database by pharmacophore. You can also simultaneously search in PDB, CSD, and your own in-house databases. It is also very fast, and you will see this in our demo and when you try to run it yourself. You can also modify hypotheses on the fly, and CrossMiner will come up with new results very quickly. Afterwards, after you conduct your pharmacophore search, you can analyze the results and filter your structures by annotations or some other properties. We'll get to this in our demo. So, to reveal more details about feature databases, as I've already said, CSD CrossMiner allows you to mine multiple data sources. You can use public data as CSD and PDB and create your own and use your own proprietary data for your search, and all this you can do simultaneously. You can find matches by pharmacophore model, and the databases which are built into the CrossMiner by default are annotated, so there is some information which can be helpful when you filter your results. And also when you create your own in-house database, you can annotate it the way you want and then filter out all the results that you need. Some more details about the databases which are built into the CrossMiner. There are 3 main databases, so you can see 4 on the screenshot, but actually this is just PDB CrossMiner database, which sources PDB. It doesn't have all the structures included into it, because the structures that we extract for built-in into CrossMiner are complexes between a ligand and a protein. So PDB CrossMiner contains binding sites of all the ligands available in PDB with some filters. For example, we don't take structures which were result using cryo-EM, or we don't take any structures that have a resolution worse than 3 angstrom for this database. Nucleic acid CrossMiner database is also coming from PDB, but the filters are a bit different. So these structures contain nucleic acid in them, and also we have a bit more loose resolution filter. So for the nucleic acid CrossMiner database, it's 3.5 angstroms. CSD545 CrossMiner and MAR24 Acer are actually databases which come from CSD. So CSD545 is our main current database, which got to the built-in cross-miner database. And March 24 is our March 20 update from this year, and this database is updated regularly, and at some point when we come up with a lot of new structures, we just create new database. Okay, so we have covered a lot about cross-miner functionality, but let's get into some basics of Pharmacophore search, and yeah, let's understand what's Pharmacophore concept in general. So you can see the definition. I can read it out. A pharmacophore is the ensemble of steric and electronic features that is necessary to ensure the optimal supramolecular interaction with a specific biological target structure and to trigger or block its biological response. This definition sounds a bit complicated. It's provided by AOPAC, so it's kind of very scientific, but we will get to the bottom of this and understand what pharmacophore is. There are still some debates around the origin of this concept, but the consensus is that pharmacophore phenomena was originated by Paul Ehrlich in 1909 and was developed by Schuller in his book Chemobiodynamics and Drug Design. And if you want to get more familiar with the debates around the pharmacophore concept origination, yeah, feel free to read a very interesting paper by Gunnar and Bowen from 2014. But yeah, to understand what pharmacophore is and to unwind this very, very sophisticated definition, let's start from another definition, which is not that solid, but very helpful when you try to understand pharmacophore concept. Pharmacophore feature is an atom or a group of atoms with spherical or electrostatic properties which are essential to the activity to a target protein. It's better actually to look at some examples to understand what pharmacophore feature is. So at the compound that you can see on the left of the slide, so I can just give you some examples of pharmacophore features. For example, in emerald green, you can see aromatic rings. In more grass-like green, these are just 6-member rings which are not aromatic. In red, you can see acceptors, and in blue, there is a hydrogen bond donor. Well, these are just simple examples. These are some functional groups which are very unique, so you can say that, well, these things, these chemical groups, can be critical for interactions with my target, so I'll call them pharmacophore features. That's how it looks in 3D, for example, on our compound. And to more understand what pharmacophore is and how it works in cross-miner, I have to introduce one more concept for you. And this concept is a pharmacophore point. Pharmacophore point is a feature that has been selected to be in a pharmacophore because its presence is necessary. So, long story short, you have a compound and it has multiple chemical groups. Some of them are important for the interactions, and you can select them as important and critical ones and describe them. And this description is basically a pharmacophore feature. To create pharmacophore feature in cross-miner, you need some pharmacophore points. Features can be described in several possible ways, but usually you need just 1 or 2 pharmacophore points to describe them. And the difference is that when you use just single point, for example, acceptor, when you describe hydrogen bond acceptor, you use just definition of any acceptor. So for example, we can see an oxygen here, and all we need is just a single point, a single sphere in its radius to describe the position and possible allowed positions of this pharmacophore feature of this chemical group. Sometimes when you have more complex features such as hydrogen bond donor, it may be important not to just point out where the donor is itself, but what's the direction of hydrogen bond. In this case, you use two pharmacophore points. In the mesh pharmacophore point, mesh sphere is the heavy atom, the hydrogen bond donor itself, and the solid surface shows the direction of this hydrogen bond. You can also customize all these features. You can, for example, add a new chemical group into definition of an existing pharmacophore feature, or you can come up with your own pharmacophore feature, or you can eliminate some undesirable patterns, some undesirable chemical groups from the description of your feature. You can also use a feature which is called excluded volume. That can be useful if you, for example, confident that some space has to be empty from any atom, from any chemical group. Then you just use excluded volume and show correspondent that nothing must be here. And yeah, now we are going to understand what pharmacophore or pharmacophore query is. And pharmacophore query is an ensemble of steric and electronic features that characterize a protein or a small molecule. So we remember that our compound has multiple chemical groups, and these chemical groups may be very important for interaction of your molecule with its target protein, and you can actually select this very important chemical group or features on your molecule, and the set of these very important, very critical features is called pharmacophore query if you work with cis-D cross-minor, or just pharmacophore if we are speaking about this in general. Creating pharmacophore query is actually a very challenging task, which requires a lot of knowledge and experience, and it's totally depending on your task and on your problem you try to solve. And we're not going to cover it during this course, but there are just some questions that answering which you can find the correct way to represent your compound as a pharmacophore query. So these questions are: what interactions are present and most common in the protein ligand complexes that you have that are relevant to the problem you're trying to solve? Which pharmacophore features are the most common among non-ligands binding to the same target? Are there any satisfying interactions that you can satisfy in the target's pocket? And are there any interactions which are very undesirable and you'd like to eliminate them? This is an example of pharmacophore query which is quite complicated and constrained. Let's understand what cross-minor allows you to introduce into your query to make it more specific. So you can see that there are multiple pharmacophore points. Some features are described with just single pharmacophore points, such as acceptor or rings, and some are using two pharmacophore points, such as blue hydrogen bond donor. So every pharmacophore point has its radius and coordinates of the center. Coordinates of these pharmacophore points help cis-D cross-minor to understand what is the relative location of the features which are critical for your query. And the radius helps it to understand what's the tolerance, how things can be shifted from the specific coordinates from the specified positions. Also in cross-minor you can actually set some constraints. For example, if you know that two pharmacophore features are coming from the same molecule, you can explicitly tell it to cross-minor and it will understand. Or if you are sure that these pharmacophore features are coming from different molecules, you can also set this up. Also, if you know that some of the features belong to small molecule, you can specify this. You can see that there is a pale green sphere, myrin2, which has letter S assigned to it. That means that it comes from the small molecule. And if you see the letter P assigned to any of the spheres, that means that this pharmacophore feature comes from a protein. If you're not sure, or if you don't care from which molecule the pharmacophore feature comes, you just let Crossminer know that you don't care. Please don't be afraid of the slide. Actually, one of the tasks of this video is not just to let you know what's Crossminer, what's pharmacophore search. We also want to let you know how it works, what's hidden under the hood. And we are starting from pharmacophore features, and we are going to understand what magic happens in Crossminer and how it understands what's what. So features are stored as text files in Crossminer. So Crossminer can read them and understand that, for example, when you define a hydrogen bond acceptor and it's a nitrogen atom, you can see that all you need is basically a smarts pattern, and there are two atoms on the picture which fit into the description. You also point to an atom where you want to put your sphere. Yeah, you remember, in this case it's just a single pharmacophore point, so you need just one sphere and you point to an atom where you want to place it. And you are setting up a type or just the name of the feature that you have there. You can see the examples of pharmacophore features which are built into Crossminer if you follow the path which I mentioned here at the bottom of the slide. As we remember, queries are sets of these features, and for Crossminer it's also just a text file. So where you have the name of your feature, the type of the molecule, where it belongs, you have coordinates and radius of the sphere, and you have some description. So that's just basically a name that allows you to differentiate which feature is where. So as I've mentioned, CSD Crossminer is a very powerful tool which allows you to solve many different problems. But during our demo and during your hands-on material, you're going to take a look on a very common workflow when you have a protein ligand complex and you know that your ligand binds to the target, but you are not really happy with its properties. What you're doing, you define the ligand and protein pharmacophore and any constraints you desire, and then you run the search and find some compounds which have the activity to the target but have some different properties. And yeah, there is just a little chit-chat on what's the Crossminer interface, and we are going to take a closer look during our demo session. So yeah, see you soon at our demo.